Welcome to my YouTube channel. Watch, like, share and comment. So welcome to my YouTube channel, and our lesson today is understanding the periodic table. My name is Mwalimu Sam Nyamu, and I go by the same name on Facebook and most importantly on YouTube, where you can be able to get my tutorials. I encourage you, after watching this clip, you watch the next clips or the next episodes that will help you understand more on the periodic table, because this one is more of an introductory lesson. So when you speak about the periodic table, the objectives of today's lesson is understanding the periodic table itself. Then we look at the first 20 elements. That is because this lesson is mainly meant for high school education. And then we have the groups in the periodic table. We will look at the periods in the periodic table. We look at the common questions that are usually tested, and then the trends across the period. And having said that, we now look at the periodic table and ask ourselves what is exactly what we are calling the periodic table. And like you can see, the periodic table was first proposed by a Russian chemist called Mendeleev in 1869. The elements are usually arranged in atomic numbers. You can change this one, cancel that mass, and let it read as the atomic number, because when we say atomic mass, it gives us something different. Remember that the atomic number is not equivalent to the atomic mass. Atomic number represents the protons in the nucleus of an atom, while the atomic mass is actually the sum of the protons and the neutrons in the nucleus of an element. So the statement is supposed to read that the elements are arranged to their according to their atomic numbers, from the first one, which is hydrogen with an atomic number of 1, to the last one, which is oganesson with an atomic number of 118. Basically, we have 118 known elements as at the time when this video is being recorded. And the arrangement of the periodic table, like you are able to see, is such that as we move from the left this side, moving towards this side, there is usually a change in the behavior in which the elements behave. That is to mean that the physical and the chemical properties keep changing as we move across the period, and that one will be explained better in our next video. So ensure that you don't miss out on this. So we have the first 20 elements, like I said, and we have the first one, which one is hydrogen. We have followed by helium. We have lithium, barium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and finally calcium. And you might be wondering how you can be able to master that one, because a good student is supposed to be able to name the 20 elements offhand. And just to mention, I have a student who was able to coin a phrase that can be used to memorize the first 20 elements, which says, according to them, that is Helen and a little baby boy called Nelson. One Friday, Nelson said that Mary and Silika picked some chapati, arrowroots, potatoes, and carrots. You are good now to go. You can pause the video for some time and try to see whether you are able to actually repeat that I don't know whether to call it an acronym, but it can help you to master the first 20 elements. So to cover the second objective, we look at the groups in the periodic table, and the groups are usually arranged in horizontal. We have the first group, here, which are numbered in Roman numbers. We have the second group, we have the third group, we have the third group, we have the fourth, we have the fifth, the sixth, group 7, and finally we have group 8. So these groups, like we said, across, as we move across the period, that is from left to the right, there is usually change in the behavior based on the physical and the chemical properties of these elements. That is to mean that the group 1 elements tend to behave differently from the group 2 elements, and that happens across the periodic table. In between here, where we have group 2 and group 3, in between, there is usually a group of elements that are called transition elements. And transition elements will be covered in the next video, so don't miss out in checking on the transition elements. So, like you can see here, the elements in group 1, the ones that we have here, are usually called alkali metals. So the members of the alkali metals include, we have lithium, followed by sodium, and finally potassium. You note that hydrogen is not included in the list for the group 1 elements. This is because it is a gas, while the elements are alkali metals. And even on the behavior, how they behave, the behavior in terms of chemical properties and the physical properties for hydrogen, it is much different. So it cannot be classified as an alkali metal. The elements in group 1 are called alkali metals simply because when they are reacted with water, they give out solutions that are strong alkaline, and for that reason they by the name alkali metals. The group 2 elements, we have the first member, which is barium, followed by magnesium, and then calcium. And these elements are generally referred to as alkaline earth metals. And they are basically called alkaline earth metals because most of them, or actually they are found on the earth, so they buy their name from the earth because most of them are just found naturally on the earth. And then we have the next very important group that we'll be looking at is the group number 7. Group number 7, for the first 20 elements, we have fluorine as the first member, followed by chlorine, and then we have bromine and iodine that are in our main periodic table, but for our purpose of learning, we just focus on the first 20 elements, and for that case, we have fluorine and chlorine. And then the last member, or the last group that I want us to look into details is the group 8 elements. Remember, these ones we called these ones group 8 elements. And the group 8 elements, for the first 20 elements, we have helium, followed by neon, and finally argon. These elements are called inert gases. And they are called inert gases because they are generally inactive. They rarely react with other elements. I forgot to mention that the common name for the group 7 elements, that is fluorine, chlorine, bromine, and iodine, is halogens, and you can be able to see halogens here. They are called halogens because they are salt producers. The name halogen comes from two Greek ones, halo and gen, where halo stands for salt and gen producer. So they are basically the salt producers, and for that case they are called salt producers, and that one now is where we get it. The next objective, unlike the groups which we said that are arranged in an horizontal order, we have the pierions which are usually arranged in the vertical order. We have period 1, period 2, period 3, and period number 4 for the first 20 elements. So the members of period 1 are usually hydrogen and helium, followed by period 2, where we have these members. Then we have period number 3, where these members follow and fall under that category. And then finally we have period 4 with these particular elements. So there are key things that you need to note here, that when we were looking at the group elements, the groups in the periodic table, for example, for elements in group 1 here, as you move down the group means coming from lithium, sodium, and finally potassium, you know that the size of the atom keeps on increasing. The size of lithium, the atomic radius of lithium is much less than the atomic radius of sodium, and potassium in this case is having the largest atomic radius, like you can see, compared to lithium, which is much smaller. The increase in this is due to the increase in the number of energy levels, and that one will be covered in the next lesson, where we'll be looking at the physical properties of group 1 elements and group 2 and so on and so forth. So when we come to the pierions, you note that as we move from one element from the left to the other, so for example beginning from lithium moving to barium, as you are able to note according to my periodic table, the size of the atoms keeps on decreasing, and the reason for this is due to the increase in the nuclear charge. You note that elements, for example, in period number 2, beginning with lithium, these are elements that have only 2 energy levels. Barium as well has 2 energy levels, and neon as well has 2 energy levels. So this means that all of these elements are having one common characteristic, that they have only 2 energy levels. But then you note that as we move from left to right, there is change in the nuclear charge. The nuclear charge comes from the protons, and therefore as the number of protons keeps on increasing, and for this case, for example, lithium has only 3 protons, while fluorine has a sum total of 9 protons, meaning that fluorine has a higher nuclear charge. So for that case, the nuclear charge attracts the electrons in the outermost energy level more strongly, and for that case, the size of the atoms keeps on decreasing from left to right. That is the same case with the elements in period 3. Like you can see that the size of sodium is much bigger than the size of chlorine, because the nuclear charge in chlorine is much higher, and for that case the electrons in the outermost energy level of chlorine are attracted much closer to the nucleus, and that makes it smaller than the sodium atom. It is also the same case with elements in period 4. So potassium, as we move from potassium get into calcium, potassium is much bigger than calcium, and the same reason for the nuclear charge, calcium becomes smaller. Yes, now up to that point, you note that that trend is not the same for neon, because from fluorine, the size of neon just drastically increases, and the same case for period 3. After chlorine, getting to argon, the size of argon drastically increases, and the reason for that is because the noble gases do not subscribe to that trend because of the... So what I'm saying is that the noble gases, their size, the atomic size is different from, is much bigger than the halogens in the same group. And the reason for that is that the noble gases have completely filled energy levels, so a repulsive force acts between the electrons, resulting in a larger atomic size compared to the halogens. So that is all with the periodic table. The common questions that you need to keep on asking yourself and try to understand is to explain why there is an increase in the size of the atoms down the group. And for that case is, for example, you explain why the size of potassium is higher, the atomic size of potassium is higher than that of lithium. Another question is explain why the size of chlorine is smaller than the size of sodium, that is based on the atomic radius, and also explain why the noble gases are much bigger compared to the halogens in the same period. So thank you for watching the lesson. I request that you watch the next video so that you don't miss out on very important facts about the first 20 elements, that is on the chemical properties, the physical properties, and the trends on the chemical properties and the physical properties of elements, or the first 20 elements.